So we're looking at non-probability sampling now. Convenience, haphazard, or accidental sampling. In this type of sampling, members of the population are chosen based on their relative ease of access to sample friends, co-workers, or shoppers at a single mall are examples of convenience sampling. Such samples are biased because researchers may unconsciously approach some kind of respondents and avoid others. And respondents who volunteer for a study may differ in unknown but important ways from others. Now, generally, this is not encouraged, like I have already explained. Okay. So when you want quality, you have to pay the price to get quality. So convenience sampling is not recommended. Okay. It's generally not recommended. Okay, so we also have consecutive sampling, also known as total enumerative sampling. The sampling techniques in which every subject meeting the criteria of inclusion is selected until the required sample size is achieved. This is not randomized, you just pick them successively. Okay. This is some people sample like this, but if you are doing real experiments and you want quality results, you don't do things, you don't do this kind of things. Okay, except in very rare, very, very rare situations. Such should never be done. Snowball sampling. No, no, there has to be some rule for your sampling. Okay, there has to be some rule. Like in the case of systematic sampling, like we said, so it's not purely random, but it is structured in such a way that it can still produce um, it can still produce reliable results. Okay. All right. So snowball sampling, the first respondent refers an acquaintance and so on. Okay. Where people refer other people to be sampled and all that. That's snowball sampling. All these are non-probability sampling. Judgment sampling or purposive sampling. The researcher chooses the sample based on who they think will be appropriate for the study. That's purposive sampling. So the person doing the sampling define the rule, the basis for the sampling. This is used primarily when there is a limited number of people that have expertise in the area being researched, or when the interest of the research is on a specific field or a small group. Different types of purposive sampling. Okay, so purposive sampling is also um, it can be used. It's a little bit, I think it's the most popular among the non-probability sampling. Quota sampling, this is similar to stratified random sampling, in which the researcher identifies subsets of the population of interest and then sets a target number for each category in the sample. Next, the researcher samples from the population of interest non-randomly until the quota are filled. Okay, so generally speaking, the most often used method of sampling is random sampling. Okay, and why? Because usually it's it produces better results. Okay, so that is that. just looked at sampling, right? Just finished with sampling. Now, sampling, where does sampling fall into? We said in statistics, the main processes are data collection, data presentation, data analysis, then interpretation of results, right? Now, when we talk about data collection, data presentation, of course, when you collect the data, there are some hidden processes that we've not mentioned now, which are sub-processes. When you collect the data, you need to organize the data, of course, okay? Organize it and, prepare it, correct whatever you need to correct, format whatever you need to format and all that. Then presentation has a lot to do with organizing further formatting, uh, you know, creating charts, creating maybe tables, professional tables, and all that. And then analysis, interpretation. So statistical sampling falls under what? Data collection, right?
Data collection.
Yes, that's data collection. Does that make sense?
Yes, sir.
Because in sampling, we said is the method of collecting samples, collecting
Data.
data from population, right? So that is data collection. So we just saw the methods of collecting data. That's what we just saw now. Okay. So the next logical thing is data presentation. But I think we've already done this topic anyway, haven't we?
It's a bit of it.
Yeah? What?
Yeah, I said we've talked about it.
Yeah. Theoretically.
I think practically
No, no,
too.
even practically, we have done it. We have done this topic. Okay.
Yeah, spiritual.
Yes, we have done all this. So we don't need to, we've already done this topic. But meanwhile, let's just look at the overview here. Data presentation, of course, we know there are different methods. We have the textual methods, right? That's writing of reports using such tools as Microsoft Word. We have the tabular method of presentation, where you use Excel, and all that to organize your data in the form of rows and columns. That's tabular presentation. Of course, we also have diagrammatic or pictorial presentation. That's what we talk about these different types of charts. Okay. So I know we've looked at pie chart, bar chart, line chart, scatter plots, histogram. We didn't quite talk about box plots. So maybe we should just look at that. We have the pie charts, also called the circle charts. We know about that. We know about the bar charts, line charts, scatter plots, uh, you know. Well, maybe I should ask you a few questions about scatter plots, about those charts. Can you tell me what is the line chart used for? What's the line chart used for?
It's for time series data.
It's for time series data. Thank you.
Yes, to represent time series.
Time series data. It's mostly used for time series data. That's nice. What kind of data do we plot with histogram? What kind of data do we use histogram to plot? What type of
It's
data?
for it's for group numeric data.
Yeah, that's good. So what would be your yardstick for making a choice between the use of pie chart and bar chart? My question clear?
Yes, sir, it's clear. It's clear.
It's just like, for example, sometimes you have to
Both
choose
of
between two things that are similar. Let's say, for example, um, you have a car like a Rolls Royce, okay, and you also have uh, something like you have a lorry and you have a Rolls Royce, and then you are invited for a party for an occasion. At that occasion, presidents and kings and CEO of international companies will be there. Okay. Um, it may not even be a lorry. Lorry is too extreme. Maybe you have a Rolls Royce and you have a something like a van. Okay. You have a van, you have a Rolls Royce. Which one are you likely to want to use to go to such an occasion?
Of course, it's Rolls Royce.
Okay. But they are both cars now. There's no one that really can't go, right? But one is more appropriate. One may be more appropriate than the other in such a situation. Okay. Well, if you want to go to a farm, you also know the type of car you want to carry to the farm. You won't carry Rolls Royce to the farm. You won't take a Rolls Royce to the farm. Okay. So, uh, pie chart is for categorical data. Bar chart is for categorical data. But what what is that little difference? So let's go. So somebody should tell us what is the yardstick? What yardstick would you use to choose between pie charts and bar charts? They are both used for categorical data, isn't it? Wonder where I stopped. Okay. Wow. All right. So I'm talking about the box plots. Let's just take it again. The box plot. The box plots. The box plots, also called the box and whisker plots, displays the 5-number summary of a set of data. The 5-number summary includes the minimum, first quartile, median, which is also the second quartile, the third quartile, and the maximum. Take note, mean is not there, okay? It's just the quantiles. In a box plot, we draw a box from the first quartile to the third quartile. A vertical line goes through the box at the median, okay? The vertical line we are talking about here is this yellow line here. Okay, but there are sometimes when the box plot is constructed, there are some vertical box plots. This is horizontal now, but the orientation can be vertical. However, the important thing is this is the median. Okay, this is the first quartile, third quartile. Notice that the box is drawn from Q1 to Q3. And Q3 minus Q1 is the IQR or interquartile range. Okay. Now, some box plots use fences. This is a fence, this line. These lines are the fences. Some don't use fences. But where a fence is used, then the position of the fence is computed using Q3 plus 1.5 times IQR. Is Q3 plus 1.5 times this gap, Q3 minus Q1. Okay. Then, of course, the minimum, the lower fence is Q1 minus, because this one is on the minus side now, minus 1.5 times IQR. Okay. So the box plot visually shows you the shape of the data. It shows you how the data is distributed. Shows you how it's distributed. Okay. It tells you how the data converges or spreads, something like that. The lower whisker extends downwards to the lowest observation that is still above the lower fence. Okay. So, look at it. Now, these are outliers. Outliers. What's called minimum here may not be the absolute minimum. Okay. There may be a few items outside of that. Those are called the outliers. That's what the dots represent. Okay. By the way, the box plot is a very useful plot for. It's very useful plot for very useful visualization. Very useful plot for data exploration. So we are going to be using it a lot, especially when we get to R. Okay. The upper whisker extends upward to the highest observation that is still below the upper fence. Okay. So it extends further. These are things we have done. Apart from box plot, which like I said, we'll deal with this much later as we move on.
I don't think we did aggregation.
Aggregation, we did.
Yeah. We did
Aggregation.
sorting, we did filtering, we did pivot tables. But for aggregation, I can't believe.
We did. Aggregation is when you talk of things like using various functions like sum, averages.
Okay. Yeah, we did.
Those kind of things. We've done all that.
Yes, we did it. Yeah.
Okay, so I think just a minute.